So tonight's presentation is the Annex 1 Contamination Control Strategy and Implementation Approach. This is by Walid El Azab. He's a Senior Manager for Technical Services of STERIS Life Sciences Belgium. And so thank you for the whole STERIS team that's here tonight. I see Richard and Neo are both here as well, so thanks for that. So Walid El Azab is an industrial pharmacist, qualified person, and Lean Six Sigma Green Belt. He's also a board member of the ISPE Belgium affiliate and secretary of the Belgium Qualified Person Association. Provides technical support related to cleaning, disinfectants, sterility assurance, and process validation. He has numerous published articles and book chapters on contamination control and is active with the A3P GIC working group on sterilization and leads the UPIP VAPI EU GMP, that's a alphabet soup right there, of Annex 1 guidance for sterile manufacturing working group and a member of the ECA task force regarding the revision of the EU GMP Annex 1. So I first met Walid at the 2018 ISPE annual conference. You guys are in for a real treat tonight. He gives a fantastic presentation. So thanks again, Walid, for your time today.
Sure.
He's calling in from Belgium, so thank you very much.
Thank you very much, Geoffrey. I hope everyone is doing well. And so the purpose of the presentation is to present an implementation layout, and it's a proposal here of a contamination control strategy across facility. So during this presentation, we will look on how to implement and also document a CCS through a 4-step. So environmental scanning, strategy formulation, strategy implementation, and then strategy evaluation, and most importantly, the communication flow here to make sure the strategy is adequately implemented. So please, if you have any questions, just do not hesitate to pose the question through the chat, and then we will look at those questions, and I try to do my best to answer to them. So first of all, let's make sure the definition are clear, and we are on the same page here. So I think the different terminology and the definition used in the Annex 1 from the revision from the version 12 is adequate. In some cases, there is some I would not say misunderstanding, but it may lead to interpretation. So this is why I want to make sure we're clear on the definition. So when we go through this presentation, it's more easier. So the first thing is contamination, and I think the Draft Annex 1 glossary is defining very well. It's the undesired introduction of impurity or of a microbial nature, the quantity, the type of microorganism, comma, I hope they put or pyrogen, or of a foreign particle matters into or onto a raw material, intermediate, active substance, or a drug product during production, sampling, packaging, repackaging, storage, or transport, with potential to adverse impact to the product quality and therefore to the patient. So if we look at contamination control, here it's about preventing the contamination into or onto a raw material, intermediate, active substance, drug product during the production, sampling, packaging, repackaging, storage, and transportation. So therefore, the contamination control strategy is a culmination of an exercise to identify activity designed to prevent microorganism, pyrogens, and or particle contamination. Again, into your intermediate, active substance, drug product, etc., until the storage. So in other words, here we go. Here we go. In other words, the CCS is also a planned set of control, and I will look at that, the planned set of control, because it's an interesting definition here. a planned set of control for microorganisms, pyrogen particles derived from current product, and I like this word, process understanding, and it's important here, and we will see why, that assure the process performance and the product quality. The control can include parameter attributes related to the drug substance, excipient, drug product material, and component, facility and equipment operating condition, in process control, finished product specification, and associated method, and the frequency of monitoring and control. I mean, this definition is very interesting, used by the Annex 1, and it's also similar to the definition of control strategy from the ICHQ 10. And we will see that it makes sense that they use this type of definition, because to define your set of control, it's really important to have a holistic understanding of your process. And it is required to have this holistic understanding. And therefore, you must have a robust technical process and contamination control expertise. So generally, this type of strategy will be developed by a cross-functional team rather than just one person, because they will need to be able to map the process, identify the source of contamination, and then define the set of control. Keep with me on those slides. I know it's boring to review the regulations, but I think it's important first to make sure we have the same understanding. So it makes sense then that the draft Annex 1 suggests that the development of a CCS requires through technical and process knowledge of the potential source of contamination that are attributable to microorganisms, cellular debris, as well as particle matters. So the source of potential contamination can only be identified by mapping and assessing the risk of contamination. I hope you all agree with me on this one. If not, please do not hesitate to ask questions, do not hesitate to challenge also, and do not hesitate to not agree to. This is with that, it's a way to, for me, improve, but also to make a discussion that is more interesting. Again, it makes also sense that the contamination control strategy should be implemented across the facility in order to assess the effectiveness of, here again, all the controls, design and procedural. I think it should also integrate technical also and structural, and the monitoring measure that has been employed based on your control plans. This assessment should lead to corrective and preventive action being taken as necessary. So this would mean that it needs to have a strategic plan where you have updates of your PQS, but also improvement of your contamination control strategy. Moreover, the CCS should consider all aspects of contamination control and its life cycle with an ongoing and periodic review and, again, update of the CCS as appropriate. So it's really a life cycle approach rather than a one-off strategy. And as a strategy, the purpose is to have a vision and then implement this vision and making sure what you have implemented as a vision is working versus your product, your facility, but also your patient as an end user of your product. Finally, and I think this is the most important thing here, is contamination control and the steps taken to minimize the risk of contamination from microbial and particle source are a series of successively linked, even and measured. That make really big sense. And we all know that, but we tend to generally just assess the issue rather than looking at all the different parameters or the successively linked event that may lead to the contaminations. So I think here the draft Annex 1 is doing a great job on defining this contamination control strategy. Is it new? We will see. I don't think it's a new concept. However, it's documented now. So if we go back now and let's try to summarize what we have seen here. So the main goal of the CCS is first to identify a set of control that is required to identify, but also to prevent, more especially prevent microbial, pyrogen, and particle contamination across your facility and your final product. second main goal, let's say like that, is to assess the collective effectiveness of all the control that you have identified. And we will see what are the type of control that you may identify, but also the measure and the monitoring that you have employed to demonstrate that you are capable of preventing this risk across the facility. So for example, in the utility, the cleaning and disinfection, your CIP system, process validation, the facility design, etc. And more important, into the final product. Again, every time I'm saying something, it's again into the final product. So I want to keep that in mind because it will make sense on how to develop the CCS strategy. The second thing is to assess the evolution of the contamination control performance over time. So it's really important to demonstrate that what you have put in place as a strategy is working. And then, if needed, you need to optimize by updating your quality system through a continuous improvement plan based on analysis, trending, and data. And we will see how to develop those data. So here is the implementation layout, where so the slide will go through that. So you will have the introduction. We're still on the introduction. Then we will be speaking on the environmental scanning. And the purpose of the environmental scanning is to refer to a process of collecting, scrutinizing, and providing information to formulate the strategies. So it has nothing to do with environmental scanning for environmental monitoring, for example. Okay, I know the word is similar, but I didn't find any other word that could be more specific. The second thing is the strategy formulation. So based on what you have scanned and based on what you have mapped, you can do your formulation of the strategy. And the goal is to decide the best course of action to accomplish the desired result. The desired result is no contamination, or at least prevent the contamination. And again, we have defined what is contamination. Then is the strategy implementation. It will be here. Okay, and the goal of the implementation is to make the strategy work as attended by the organization, procedure, controls, monitoring, resources that is needed, and also develop the decision-making tools that is needed to take decision. And so you have at least something that is more harmonized between across the facility or even between facilities, if it is applicable, of course. And then the last step. There we go. The strategy evaluation. And in that case, really, the strategy evaluation is it can be similar to a strategy control, which is measuring the performance of the process and the strategy that you have put in place. So what you want to make sure is the strategy that you have put in place, again, is working. So if we go to the first step, environmental scanning, I think here it's the list what the Annex 1 is using. And again, like I say, it's a process of collecting, scrutinizing, and providing information to formulate the strategy. And so what you will do is look at the facility design, equipment, the personnel, and I will go in the deep dive and use an example so it make more sense. And then look at all those different parameters. In this slide, I also added the quality target product profile. And because it's an important parameter, and I'm pretty sure this will lead and will define the bone of your CCS strategy, because it will be based on the type of product. Is it a sterile, non-sterile, and the patient. And the patient who is taking this product is very important. So it will also depend on the status of the patient. Is it immunodeficient patient, patient with high risk, or a normal patient? When I say normal, I mean with less risk that the drug will be administered. So let's try to translate this theory through an example. So in this, I'm referring in this example, I'm referring to the Bioforum environmental monitoring in modern biopharma drug product facility. And it's a proposal for a harmonized risk-based approach to selecting monitoring point and defining monitoring plan. Sorry, the title is very long, but I had to read the source because it's not coming from me. It's coming from a source from the Bioforum. And I think it's a very good document for those who are working in EM or even in contamination control. read it. And it fit the purpose here on for the presentation, because I will be looking at how to map your process, how to identify the source of contamination, how to assess your risk, and how to implement your procedure or even your control. So really the first step here is to scan the environment. And so in that case, so the first step is to look at the filling process, upstream process, and the support area. So they will look at that. And so let's see how it looks like. And any companies or any CEO or even senior management, when they have to develop a strategy, they need to look outside. What is the environment? How is the voice of customer? What is the marketing tell? What is the TMIC? So what are the capabilities? So this is what we're trying to do with contamination control strategy. And then here, the goal is in that case, they lay out the facility, and then they focus here on the in-feed grinding. So where there is the deperogenation of the glasses before being used into aseptic area. So here is really understanding where are the process. So in your cases, for example, try to assess, is my facility a multi-product facility? Is it sterile, non-sterile? Where are the process being performed, high-risk process, downstream, upstream, etc. Where are the grade area? How is the personal flow? How is the product flow? Where are the different grade area? All that needs to be taken into account when you are doing your scanning, because you will see that the way the strategy will be implemented may be different versus the risk of contamination. So if we go back to the theory, so this is a slide from the theory. I want you to keep in mind this slide, because I will be populating it through the presentation. So it will make more sense at the end of the presentation while there's all those squares. And again, like I said, the first thing is to scan your environment through facility, premises, equipment, utilities, etc. And here I also added human factor. I think it's very important. I mean, it's the bone of your PQS, so the pharmaceutical quality system, but also the bone of being able to produce. Even if we try to put them at least less intervention with the product through isolator and wraps, but still. Like I said, you want also to understand when you are doing your environment scanning, what is your current risk of contamination? Do you have an overall risk assessment on contamination that is taken into account? Okay. So the goal of the environmental scanning is really to help develop effective CCS formulation that fit your product and fit the patient risk. So by this, it means that the CCS is not only applicable for sterile product, but it's also applicable for non-sterile product. Sterile product is it's super easy with sterile product because it needs to be sterile. So that means no contamination into the final product. For a non-sterile product, there is a challenge, because non-sterile by definition means you can have some level of bioburden into your product. As a consequences, you need to understand what is the contamination. In that case, what are for example, the objectionable microorganisms that may lead to contaminate your non-sterile product or may lead to alter the quality of your product. Or if I have a bioburden that is below the limit of the USP or even the European pharmacopoeia, whatever pharmacopoeia you are using, during the stability, is there an impact or potential impact on your product? Okay, so for me, I think developing a CCS for a non-sterile will be more challenging than for a sterile. Now let's go to the strategy formulation. This figure will also be populated, so try to keep track on this figure too. So like I said, the first thing is environmental scanning. The second thing is strategy formulation. To be able to do that, what you really need is to bathe through the surrounding environment and the activity where the product is processed and transported. And also by identifying and understanding the quality target product profile and the target patient. So this is why production process is is separated. So here there is the production process, really the focus on the product itself. And here it's everything that is around the product. So the people, the raw material, excipient, facility, cleaning equipment, isolator, wraps, environmental monitoring, all will be here for that case. And again, I think there is good documents like the ISPE 111 to reference for objectionable microorganisms. I think there is a great document from the PDA on Technical Report 67 that is developing well on how to define your objectionable microorganisms. So in conclusion, the goal of the formulation of the CCS is to be dictated by the quality product profile. Quality target product profile, sorry, and the environment where the product is manufactured and transported. So the CCS here aim to ensure the process performance and preventing contamination into the product, but also during the productions of this. So as you can see, formulation of the strategy will be very easy if you have done adequate environmental scanning of your process. So this is why there is not a lots of slides on strategy formulation, because if you prepare adequately, the implementation goes quickly. So now let's keep up on the implement the strategy. The first thing is you want to make sure for the strategy to work as attending, you want to make sure you have adequately mapped the different organization, let's say like that, or different element of the contamination control strategy, but also the different element that is needed to produce the product and prevent contamination. So by that, you will try to map your different process through the procedures, the different organizational activities. We will look at that. So the personnel flow, everything, the resources. Do you have enough resources to implement the strategy too? Equipment, the design of the equipment, how the equipment. So you will have to do a risk assessment on contamination of the equipment, the different controls and the different decision mapping. So why mapping the process is critical? Because it will help you to identify the element of your risk assessment and developing also a good process knowledge. It's only by doing mapping of the process you will develop an adequate process knowledge and be able to take the right decision based on your product and not just based on what the regulation is saying. So let's get back to our example, and really I invite you to read this document because it's well done, and then I will stop to say that. So the purpose here, so what they did, you remember the grid, they map each grid that they have developed. So they have 8 grids for one facility, which was the in-feed, and so they map the process and explain what happened to the glass to be depyrogenated, and each step is really explained. And these steps will be taken into account to develop your risk assessment. Again, why I'm focusing on risk assessment, because this is the source to develop your controls. And again, CCS is about controls. So what they did is they mapped this facility here, and they look at the number 1, 2, 3, 4, 5, 6, 7, 8, and they develop what happened in each sections. And the goal here is to assess the level of the risk. So as I said, the mapping of the pharmaceutical process is really critical to first define your element of the risk and develop the process knowledge. By identifying the source of contamination, you will be able to evaluate the risk. It is acceptable for you as a manufacturer to use your existing risk assessment, such as microbial, bioburden, particulate product risk assessment. However, you want to make sure that those risk assessments that currently you have into your facility is covering the CCS purpose and are still up to date. So if it is 5 years old or 10 years old, you may want to revisit those risk assessments. So try not to reinvent the wheel. The wheel. Use what you have. You already have a lot. So now you have developed your risk assessment based on the mapping of your process and understanding the different source of contaminations. what you can do is, let's go back to our exercise. They have defined each level of risk depending of each process that have been mapped. And I like this because what they did is then created a heat map of a relative probability of risk of contamination to help deciding where to remediate and where the control must be implemented. And I think this heat map, if you are developing those type of heat map, is really I think it's an excellent tool for when you have a deviation. Or you have a deviation due to contaminations from microparticles or pyrogen, because you can go through your heat map and understand if the deviation came through across an area where you already know that there is a high risk, and maybe the measure that you have implemented is not effective or is not adequate or needs to be optimized. So you do it one time, but it has to be used every time because the deviation you generally have a lot. But then you want to make sure you revisit that based on the different kappa you will be implementing to improve your process. And then this is why risk assessment is really important, because it helps you to define your control element, and the controls can include parameter and attribute related to the drug substance, like say by the Draft Annex 1, excipient, drug material, and component of the facility and the equipment operating condition. So that would mean in-process control, finished product specification, and any associated method and frequency of monitoring and control. So you will have to do, I mean, I say you will have to do because you are the end user, and I'm a supplier in this case. But let's say we will have to do this type of mapping of the process and risk assessment for every different parameter and element that has been identified through the environmental scanning. So normally it should be done for human factors or personnel, for the RABs, for the isolator, HVAC, I mean, your sterility assurance test, media field, etc. So you can imagine the huge amount of work. However, it's already been done. It's just everywhere, not in a one document. Also, what you want to make sure is those type of control include the kappa to make sure it's improved. So here it's go a little bit beyond of the manufacturing, it's go also before the manufacturing. So everything that is related to vendor, supplier, and third party, but also after transport until it gets to the patient. So the CCS cover all of those, where generally it was more as a siloed between department. And Bixby is here. So then when you have defined your control plan, the monitoring location and frequency is implementing across your risk of contamination, but also based on your control plan. So what I mean by here is, you remember this slide, at least this figure, there was only this. So only the environmental scanning and what you have done. And then what you will be doing is a process mapping of every step of at least here of every element. And then develop the risk assessment. Here only focus on contamination, okay? Not anything else. And then develop here your risk assessment. And the goal of the risk assessment is to define your control parameter, your control plan, sorry. And then you will be mapping your monitoring plan. So that's mean you have your control plan and then the monitoring. So where I will be monitoring the frequency, etc., and making sure you are taking track of this and trending that. And of course, based on that, you will be developing the procedures for facilities, for premises, for equipment, for utilities, for personnel, etc. This is if you have. This is easy if it is a new facility, because you have to do everything. If it is an existing if it is a new facility, also instead of process mapping, it will be designing the process. Okay. If it is an existing facility, you want to make sure you reuse what you have, and maybe revisit if it is not up to date, or if it is not, or if it doesn't fit the purpose of the CCS. So by revisiting is redo the process mapping, of course, reassess if the risk assessment and the result of the risk assessment is still up to date. And if not, then you will have to revisit it and redo it. And then reassess if the control plan that is in place is okay, or do I need to add it, remove? It's okay to remove sometimes, but you have to have a good justification. And then have your monitoring and your SOPs, okay? So through the implementation, you are already here, okay? Of course, there will be deviation and kappa. I didn't put it here. It will come afterwards. Good? Good. So then you have, back to our example, you have defining your control plan based on your risk assessment. Then you put the monitoring location and the frequency of each according to your control plan and your risk of contamination. And then what is important when you put those type of monitoring and where to look is to look at the historical monitoring data. It has to be collected, it has to be analyzed and trended. And the goal of doing that, collecting, trending, and analyzing it, is not to make auditor happy, is to confirm that the process, performance, and the product quality over time. So that's the goal of the trending. And also confirm that the deviation that you may had and the kappa that you have implemented and the root cause that you have had identified is correct, working, and effective. So that would mean, potentially based on what I'm saying, is every kappa that you are identifying into your system needs to be logged in to the CCS, or any change that may impact the CCS or impact the facility or impact the risk assessment overall needs to be logged in again to the CCS. I will show you that afterwards. So let's conclude about the implementation. I hope it is clear based on the example that I used to make it more easier, at least to understand. And why I'm doing that is it's just funny. But few weeks or maybe months, I don't remember. But I did a webinar in China for China, and I'm presented about contamination control, and I directly go into the deep dive of where to look, how to do it, and etc. And at the end of the presentation, I should not say that, but a lady told me, so where do we start? Okay. So this is why I try to make it very divided in every step, so you understand where to start and where to at least to loop to finish the loop and close this. But it was a very good question because it helped me to review and revisit the way to present it. So the so number 3. So number 1 was environmental scanning. Number 2 was strategy formulation. Number 3 is implement the strategy. Okay. And the goal here is, like I said, the first thing of implementing is either design the process if it is a new process, or map the process if it is an existing process, and then identify the source of contamination for every step. It's a huge work. And then based on that, perform your, here it's the environment is not environment, controlled environment is all the surrounding environment of to produce a product. Contamination risk assessment, and here it's the product contamination risk assessment. So really for the product and for the environment, I just separated them, but at the end it's all together. Why? Because after you will need to define your contamination control plan. So here is define where you will be sampling, where you will be taking your control, or even how to design your procedure. So it should include everything that is related to design. So design of the facility, design of the HVAC, this equipment design that is adequate to the engineering. So here I advise you to read the ISPE guideline on how to design equipments so you don't have issues, or even on sterilizations. And then on the procedures, on the way to clean and disinfect, sterilize, aseptic manipulation, aseptic intervention, etc. Technical, in that case, the technical is about preventive maintenance, but also technology implementations. And it's important to, the level of risk will depend also on the technology that you have implementing into your facility. So an old technology or an old facility will not be as performant as a new facility with new technology, let's say modern technology. Okay, it's exactly the same as a car. So don't compare two different facilities when you are doing your CCS performance. It needs to be taking into account the fact that the facility is I don't know if it is adequate to say old, but it has some challenges, and you need to improve those challenges to make sure that the product you are producing is the same everywhere, despite the type of facility. Then also in the control plans, you want to make sure you're taking also into account the organization. So resource location is important because you can't do everything in one time. the work shift of the people, decision-making process, and the most important thing is the trainings of the people, making sure you have adequately transferred this knowledge and adequately transfer this knowledge, but also the understanding of why you are doing this. Okay. So really, in summary, the goal of implementation is to identify of control, executing the strategic plan. In that case, this means executing the strategy as a vision. So that means the strategy formulation, and then of course manage the implementation by priority over time. You can't do everything, so you have to be able to develop a decision making of what is priority, what is a priority, and what is not a priority. Okay. And we will see how this may take into account. The other thing of the implementation that is important is the communication and the implementation process of the CCS. And this has to be done by a cross-functional team. And a key success to effective CCS implementation is a good communication between department and a collective work between department and people. So if you are in silos, you need to be together. That's what it means. And it has to be done by a cross-functional team. Here I put some example: QC, production, validation, regulatory, QA, maintenance, but you can go further. Okay, I have a slide. I can put everyone. And I believe that this cross-functional team needs to be led by quality assurance, QC, but when I say QC, it's a senior microbiologist expert and a process expert from the production. I mean, the main thing is production and people from validation, but also from the transfer and etc. But you want to have someone that have a great expertise of the process production to support this team, but also making sure that the communication include the feedback from the field to this team, so to this global team, and the communication is also going back to the field, to the vendors, to the transport or GDP subject matters. Okay, and you want to make sure that this team is designing the vision, designing the decision tool based on input from people that is on the field. Okay, you want to make sure the sky is on the field and not the contrary. I hope I'm clear on that. And also be able to address gaps and identify on the performance. I think there is a publication from Takeda on this, on how they implemented the CCS as a communication tool between department and across facility. That is very interesting. I'll try to get this the reference again. So now we are in the strategy evaluation. So the goal here is to be able to assess the efficiency and the effectiveness of the CCS performance. So how do we do that? So let's I mean, I want you to think about it. How can I do that, and what are the way to do that? I mean, you say I have to map up the process, assess the risk of all the process, develop a control of the process. Can you imagine what it is? So it's huge. It's really huge. And really you will need to assess the historical performance and reassess the data trending. For me, I do believe that the way to assess the performance of the CCS is based on the overall risk. So what I mean by the overall risk is the RPN value, or the residual risk of each process over time for contamination. So here it's an example that I used, okay, where N is, let's say 2020, 2016, 17, 2018, 2019, okay? And then what happened is you look at all the facilities and you did a risk assessment for everything that is related to facilities. So facility design, HVAC, not the HVAC, facility design, and the way the people is entering, etc. And then you do an overall risk assessment of this. So you have different risk assessment, and then you calculate each RPN, and then you put a number on this, or you do an addition of this or a multiplication based on what you think is the overall for the facility. Then you do the same thing for the utilities, equipment, etc. And it must, so the goal is to consider, to understand the performance and the efficiency of what you have implemented, is you need to have and to demonstrate the effectiveness over time. So this is why you will be doing the same thing, for example, every 6 months or every year. I think to do that, it's a huge work to do that every 6 months. I believe it would be, I don't know. I don't want to put any frequencies, because I think it should be based on, and it should be commensurated based on the risk to the patient and based on the risk to the product. But I think it will not be done every month at least, except if you are very good on using modern technology to update the risk assessment directly. Maybe it's an idea. And the way to do that is after you have this dashboard. Sorry, it's going too fast. You have this dashboard that is looking at facility design. The blue one is N. The orange one here, but here you can't see it because it's the same as the blue one, is N+1, and then N+2, and then N+3. So what we can see here is there is an increase at N+2 in the risk for the facility design. Okay. Here, there is an increase in the risk for utilities. And so if we look at the N+3, here there is a risk for product cleaning validation, for example. There is a risk, the risk is increased based on what have been in the previous year. So that means maybe here you need to implement improvement to be able to reduce this risk and be able to have it in the safe zone. You will again have to identify where is your threshold. Is it 2? Is it 3? Is it 4? That would depend again on the risk to the patient and the risk to the product. I hope this slide is clear. So the goal is to evaluate the risk, the overall RPN of each segment that I have identified to be important, and then to assess if the evolution of this risk is increasing or decreasing. This is not the only KPIs that you may use, because like I said, to perform this, it's a huge work, because you have to revisit all risk assessment based on all the deviation that has been performed, based on all the monitoring data that has been gathered, etc., and the CAPA that has been implemented. So I do believe that you need other KPIs that can be analyzed and more frequently. And you should identify those KPI that trigger that has been the KPI should be triggered by contaminations, and to be able to have quick actions, at least, like say like that, to improve or at least to revisit the CCS performance. So let me go at that. And again, I think the frequency of evaluating those KPI as an overall will depend on the risk to the patient and risk to the product, or any changes that may bring. So this is an example of KPI that can be triggered by microbial, pyrogen, or endotoxin contaminations. So for example, this one would be easier to look at it every month, every 2 months, or every week, or etc., or even every day during your checking during the checking in shop floor. So the goal here is to look at deviations, not all the deviation, but only the deviation that is triggered by microbial, pyrogen, or endotoxin contamination. The red line is your threshold, so that means the limit where you are. So we can see here, it's not very under control, okay? And deviation. So here it's the number of deviation related to specific area of a risk. So for example, if you are a sterile manufacturer, maybe in the ISO 5, the number of deviation in ISO 5, or maybe even in grade B. But try to focus on specific KPIs that will give you a great idea of what is happening into your facility, rather than having lots of KPI and not understanding where you are looking for. Sterility test. I mean, this one is easy.
We had a quick question that I think maybe is I'll ask here. The question is, where do the RPN values 3, 4, 5 come from?
Yes. So in that case, this is example. So what I use is 1, 2, 3, 4, 5. So 1 less risk, 5 is high risk. Okay. So let's take an example. You perform your facility design risk assessment, for example. So you will look at each parameter, or let's say each element of this facility design, like we say. So map the process, map everything that is related to facility design, and then you will put a number. So the occurrence of contamination, the severity, and the detection. Do I have a system to detect this? You will have for each one a number. And what I'm trying to do is after to have a total number, and this total number is to put it into a scale that is between 1 to 5. So divided by the, so let's say you have 500, and when you have performed your risk assessment, so you know what? It's more easier when you can write, because I want to make sure everyone understand that. Then. So let's take this example, okay? And let's look at the example that we have seen from the risk assessment. So what they did is for the feed line, also for the glass dehydrogenization. So that means for anything that is related to dehydrogenization. Okay, sorry. They will have a different. So for dehydrogenization process, they will have different lines of risk. Okay, so this is the items. And then here it's the occurrency, the severity, the detection, and then you have here your level of RPN for each step. Step 1, step 2, step 3, etc. Okay? And then they will do the same thing for sterilization, for example, that is still, so where is my mouse? Here. For sterilization, that is still into the process, let's say, of product productions, okay? Product process. So they will do for the sterilization the same risk assessment of risk of contamination. So from having the product, so having the cleaning the item, wrapping the item, let's say like that, perform the sterilization. After the sterilization, you have your hold time, etc., and then unwrapping the item, bringing it to the wraps, etc. So you will have every time your severity, occurrency, detection, and then the level of RPN. Okay. And then at the end here, you have a total. Here you have another total. Let's say this is X and this is Y. What happened is for this element, which is one element that I have into my environmental scanning, so let's say it's facility, okay? I will have a number that is X, either you do X plus Y, but I believe multiplication will be easier, but let's do that. X plus Y equals Z, okay? So Z may be 500. Either you take this number and put it into the RPN, or to make it easy to understand through a graph, is to put this number into a scale that is between 1 to 5. And this will be, you will need to identify what is here the maximum RPN I can have for X and Y, and do X plus Y is equal, for example, equal W. This is the high RPN maximum, so that would mean equal to 5. It's three stuff. So how do you say that? I don't know how do you say it in English. So maybe this is why I'm doing that. But and then you will look at what is the minimum RPN I can have for X and Y. And in that case, for minimum RPN, X and Y will be equal to A, which is A is related to a 1, W is related to a 5, and then Z, it will be the number divided by whatever on the scale to have which number, 2, 3, or 4. Am I clear? You can say no if it is not.
I think it's pretty clear.
Okay. And so why to put it?
The drawing skills are a little not so easy with the mouse. But it's, I think everyone understands.
Okay, good. So okay, I don't know how to maybe thank. Okay, good. Let's go back. Yes. So okay, so this is why you need to have the same numbers, so it's easier as a dashboard to look at the overall risk. You can put that in percentage, whatever, but I think this is the way I wanted to share. Then is look at the different other KPI that you may have that is important. Like we say, deviation, the number of deviation into your ISO 5 or even for sterility test. Normally it should have 0 on that case. And for a non-sterile, for example, microbial final test released, where you can look at if there is any microbial contamination into the final product. Okay. Oh yeah. Oops. There we go. Then you have, you can look at rejected batches, so the number of batches that has been rejected through each month in that case, and understand why they have been rejected. And it has to be rejected due to microbial, pyrogen, or endotoxin contamination, or even particles contamination in that case. Here, you should add a particle into the title. There is a missing here, it's particle, 2 particle matters. Other stuff, for example, for aseptic manufacturer, failed aseptic media simulation and a percentage based on the last one and the current one and the last one. Is there a failure or at least a failure between the last one and the other one that may trigger something? Another thing is the number of complaints coming from the market. That's very important because it links back what you have been doing into the production. And when I was at QP, I wanted to know what are the complaints that is coming from the market to understand if potentially there is an impact on my production process and what I have been releasing on the market. Another thing is for aseptic manufacturer is the percentage of disqualified aseptic operator. So if you start to see a trending in that means there is something wrong. We can say it like that, and you need to readdress that. So this is quick KPIs that will allow you to quickly address deviations, or let's say an increased trend that you don't want to have based on your CCS strategy and based on what you want to implement. Number of recalls, 0. And this manufacturer is excellent. They don't have anyone. But then also you want to look at the percentage of the CAPA that has been implemented versus the strategic plan. In that case, the strategic plan is based on the CCS itself. And I will show you after what I mean by that. But really is what I have identified during the strategy evaluation of element that I need or CAPA that I need to implement through the facility, premises, equipment, utilities, personnel, etc., to be able to reduce my overall risk based on the previous slide that I show you, and see if there is a trend into increase in implementation. So in green, orange, it means there is a standby, or we don't increase versus, for example, last month, last 3 months, etc. And then the last thing is to be able to use those KPI. Okay, it's an example, so for me it's easy to do that, but it's to be able to use those KPI and assess what is my monthly performance. Okay, here I put 85% because there is nothing very inadequate for June. We are in June, except here maybe 30 versus 20. So this is why it's an 85. Okay. However, I think for you it's to be able to develop a calculation based on the first the KPI itself, the ponderation of the KPI, the importance of the KPI itself. So some may have a high ponderation, for example, those one versus this one. So deviation into an ISO 5 or sterility or microbial testing at the end. And for the final product will be higher for versus a deviation during the process that can be handled in some cases a fail. And so by this is develop a ponderation and develop your heat map for every month. Production. Yes. Is there any question? No. So that can be reviewed after by the cross-functional team and also communicate to the production, but also to any person or any department that is need to have those type of information. Okay. So now let's go back to this figure. Now it's been very adequately populated. And let me try to summarize this figure, okay? So really, again, like I say, the CCS is a culmination of an exercise to identify activity design to prevent microorganisms, pyrogen, particulates, contamination in the product, and supporting processes. So that's mean anything that is around, like facility, premises, equipment, utilities, etc. And this means you have to look at from, like I said, the process mapping, risk assessment, control plan, monitoring plan, SOP, deviations, and kappa. So deviation may come from non-complying with the SOPs or etc. And then you will have kappa. Those kappa needs to be logged in into the strategic plan. And I will show you how. You remember the draft Annex 1 is suggesting that you need to have a collective analysis of each element of the contamination, or at least of the parameter that you have implemented, to understand how this collective element may bring contamination or may alter your CCS performance. So this is why there is those boxes into those little boxes that taking into account. So you have to take all into account before going to the to perform your data trending analysis, and before going to added more kappa or more improvement into your strategic plan. So the strategic plan means I have the list of all the improvement that I want to put in place, and the strategic plan as it is, it means I'm prioritizing what in the list, what is priority number 1, 2, 3, 4, 5, for example. And then you have the, like I say, kappa, and then you have change control. So I put the change control here, a little bit a standalone between the PQS and between the CCS here. So this box in blue, little blue, this, and the whole gray is really the whole CCS. Really, when you look at this, it's not something new. We already have everything of that. Everything of that is already implementing into your facility. The only thing is we don't have this little document called Contamination Control Strategy that is gathering all the different information and put everything into one, let's say, one good document where you have a clear strategy for contamination control strategy for the overall from into your facility, before from the vendor and until the transfer station. Change control is important. Generally, will be lead from kappa or new project or for authority, etc. But generally, it's a kappa who led to a CCS, change control, and then we'll bring updates to the SOP and to the control plans, etc. So this is why it needs to be linked to the PQS. And so this is why you have a double flow communication between the PQS or pharmaceutical quality system and the different change controls. And also those type of change control, the overall changes control. So all the change control needs to be taken into account versus the strategic plan and into the PQS. Okay, you remember we all had this type of issue. Little change, no impact, little change, no impact, little change, no impact. And when you look at the whole little change, there is a huge impact. Okay, so this is why it's important to have this holistic view and this holistic periodic review of different change, kappa, deviation, etc. And then by updating the PQS through the strategic plan, so it's a double flow communication, then you can update your PQS and then start to update, facility, improve your equipment design, improve your premises, revisit the utilities, retrain the personnel, for example, on aseptic infill prevention, aseptic media field, etc. Review your vendor, asking for tighter, for example, limits, etc. Okay. Here you can see I put a human factor is a little bit different. Human factor is about mapping his process. It's good to do a risk assessment of human factor, even if it's not easy. And generally, it's implemented into the different element of the PQS. Here is the training plan, and then the qualification plan, and then having your SOP for the people. And then here is knowledge management. You want to make sure you have a knowledge management here, not just about the people, but also about your processes, etc. I saw something that was very interesting when I did an audit few years ago. It was in UK, and I still remember when I did the audit, I asked the person, so when the person is ill for a long time, what happened? And so what they have a procedure for if someone is ill or leaving the company for a long time, on how they can reassess, even for 1 week, 2 weeks, how they can reassess his knowledge and reassess that is still okay versus what he has done, or versus the procedure, or versus the activity he needs to be done. And I really like the way it was developed, rather than just saying in the procedure you need to be trained on that. And voilà, like you can see, it's a life cycle loop, and it's all turning around the it's all turning around the PQS, not the CCS. It's all turning around the PQS. The CCS is here to support the PQS, and it's just here to have an overall understanding of risk of contaminations through the different element of your PQS, so facility, premises, etc. Okay. So if we go to the conclusion of strategy evaluation. So like we said, the goal of the strategy evaluation is so if we look at the document as itself, in this part, when you say strategy evaluation, it must contain the different KPIs to be evaluated and at a defined frequency. So it's up to you to define the frequency. Again, based on your risk, based on your patient risk, and based on the product risk. Okay, so three things: contamination risk, production, patient risk, and product risk. It should also discuss how the strategic plan will be developed and the element that will be taken into account based on the data trending and the data analysis that you have performed. And it's important to prioritize what you will be doing. Otherwise, it's all over the place. And I think you all know that if you, we all work in the industry. We started lots of projects, and then half of them is just in standby. Sometimes it's 2 years standby, and half of them, or maybe 30%, 20% even, is only finished, or 30% is finished. So you want to make sure you're prioritizing that, because this will require resources, money, etc. Finally, you want to make sure also you have a robust decision-making process. If I have an issue, what I'm doing. And it's important to ensure an ongoing CCS performance, but also confirm this performance, and at least maintain this performance over time. So as a conclusion,
another question for you, Walid.
Yes.
The question is for the human factors. What does the QP mean?
Qualification plan, qualification of the people. Do I need to qualify them or not?
Okay,
Yeah, it doesn't
cool.
mean qualify person.
All right. Thanks, that's a good question.
Yeah, I agree. Yes, let's go back. So as a conclusion, I think this term and the CCS is a culmination, and really it's a culmination. I like this word, and it's not coming from me, I promise. It's a culmination of an exercise to identify activities designed to really prevent microorganisms, pyrogen, and particulates. So like you can see here now, you have the overall architecture of the figures that I was showing every time at the conclusion of each sections. And I think the content of your CCS document could be documented using this flow, and I hope it will be useful for you to be used. Again, as a conclusion, so as a manufacturer, you can formulate your contamination control strategy based on the quality target profile. I think this is the main thing, and this will be the bone on the way to develop the strategy, and the environment and the process that is used to manufacture the product, transport the product, or to. The strategy implementation is involving and is about involving and executing the strategy plan, and also managing the plan by priority over time. And the last thing is the evaluation, and really the goal of the evaluation is to allow you to identify new strategic plan to support improvement, new measures, new controls, or even to streamline or to lean your processes to the desired result. And the desired result in the CCS is about preventing contamination, not controlling contamination, because it's two different words. It's really about preventing the contamination, okay? So by that, thank you very much for your time, for your listening. for also the questions. And please feel free to ask any question, and I will do my best to answer to them. Thank you.
Waleed, thank you so much. Sorry, you would. There's been 100+ people listening, and you would get a good round of applause right now. But
thank you.
We're limited by technology here, but it was a fantastic presentation, and I think everyone took away a lot. There's a lot of kudos in chat right now. For questions, I have a couple of questions I can ask, but before I do that, you're welcome. Anyone is welcome to come off mute if you like and ask a question, or you can put into the chat and ask. I'll give it a couple of seconds here before I ask the first one. Okay, let me, one question I got was, is the level of the CCS, the Control Contamination Strategy, to implement for non-sterile should be identical to a sterile product?
Yeah, good question. No, I think the level, again, the level of the CCL will be commensurate by the risk to the product, the risk of the product, and also the quality target profile of the product. So if it is a non-sterile, I think there is, I mean, I won't say there is a so the amount of documentation for a non-sterile versus a sterile, I think will be different, will be maybe lower. As you can see also during the KPIs, we saw that there is more KPI related to, you know, micro and aseptic manipulations. That is more related to the sterile. So I think it will be lower. However, it will be more of a challenge because you would need to develop more knowledge about objectionable microorganisms and about what is a real contamination for a non-sterile versus a sterile product, which is more easier for the sterile product is none.
Thanks for that. Another question that just showed up in the chat is, when will the Annex 1 update be implemented?
That's a great question.
I mean, take a look into your crystal ball for us.
Yeah, I can look at that. So the only thing that I can say is there is currently a targeted review by different associations. So ACA, AIPG, A3P, PDA, ISPE also is involved, and other associations. I know it has to be. We had to give the comment before June, but due to COVID, the prolonging, I think, to July, 20 July, and then it's just a matter of time. If I look at my ball will be between maybe the first semester of 2021, but I can't guarantee anything. I mean, I don't know, to be honest.
Okay, well, we'll quote you on that one. I got another question there. Why the CCS should be based on the QTTP rather than the process step where the contamination may occur?
Oh yeah. Really the goal of the so if I understand correctly, your question is why it should be based on the QTTP instead of, you know, just the steps. So that would mean if I'm on a bulk, it's a non-sterile. The bulk is a non-sterile bioburden control, so I should develop my CCS based on based on a non-sterile product, for example.
Right.
Yeah. So the goal of a strategy in that case is an overall strategy. So if the bulk is a little bit contaminated, let's say like that, or have a high level of bioburden versus the normality that you are routinely having, how this will impact the formulated. So if I look as a silo, then I will only be looking as just one perspective of the manufacturing without taking into consideration the overall and the holistic approach. And here the Draft Annex 1 is it wants to take the holistic approach, and by that's mean my first step is the final product. So this will be the one that is leading the different limits, let's say like that. So it's like also for non-sterile. The final product will be leading the different limits, and then I will adapt the limits based on the step of the process, and of course I will be adapting the controls based on the step of the process. So this is why you are performing a risk assessment for every step and identifying the risk of contamination based on this step. However, taking into consideration the overall strategy of preventing contaminations. I think it makes sense if we look at it as, let's say if you look at the more basic as a cleaning validation, you have to take the whole train of surfaces that is in contact with the product or in contact with multi-product. And if you are looking at just one train, so I would say, I'm just looking at the vessel and I will put the limit for this vessel. Yes, your limit for the vessel will be good, but if you take it as an overall, the limit won't be good anymore.
All right, thanks, Wally. I have one last question here, but does anyone else have anything? You're welcome to come off mute if you like, or can put into chat. Who is the main responsible to make the CCS in a company? I guess main person, or what would their position be? The main person responsible to make it in a company.
Yeah, I think so if we look at the chapter 1 is senior management, and then identifying the real person. But if we look at the chapter 1 from the hydraulics and even the PICS, it's the senior management is responsible to ensuring that that the CCS is adequately implemented, but also that the resources is here, everything is here to make it happen. And in Europe, and even in some countries in Asia or South America, the QP is also responsible to making sure it is adequately implemented, because it will impact his certifications and releasing the batches based on this overall CCS. And again, it puts more I think this CCS is putting more responsibilities on us as a manufacturer, and because you won't be able to say, yeah, but we didn't know it, or it was here, not here, and it's not a holistic. And even for the QP, putting more responsibility to him there wouldn't be no excuses like, okay, we didn't see it. You have to see it because you had to do a holistic understanding and holistic mapping of your process. So
you're kind of out here. Wally,
yes,
sorry.
And again, it's everyone's responsibility, especially production, people on the floor, and operators, everyone's responsibility to making sure it's working. So without the people, nothing will be working. Neither the CCS, neither the PQS.
Great. I think that was a good question. Thanks for asking that. I got one more question in chat before I ask you that though. I would like, could you take a second to plug what other topics that and webinars that maybe yourself or STERIS does? And for those interested, you could send the ISPE Sing affiliate email, and we can collect responses if there's interest in other STERIS presentations. So I think you do more than just the Annex 1 talk, Walid?
Yes, sorry. Yeah, so in STERIS, so there is different people like me, and we are more than 20 all over the world. So there is Richard Shai, which is located in Asia, in the US, the Jim Pollerine, Paul Lopolito, Elizabeth Rivera, Bess, etc. And we are doing a lot of training, seminars, and support to customers through anything that is related to contamination control, which means cleaning, sterilization, cleaning and disinfection, wrapping of systems, and sterility assurance level. This is also through Aaron Merton from the US. And we do that through either STERIS or through ISPE, PDA, And so if you are interested on that, yes, we can share a list of what we have for this year.
Yeah, that'd be fantastic. You can, and if anyone that's on the call is interested, reach out to us, and we're quite keen on getting feedback from our members, and we can coordinate with the STERIS team to make that happen. Before we go, I think got one final question that I think is a good last question to end on, and that is, what is the most contributing factor for failure of control? Would that be humans or machines?
I mean, that's a great question.
Yeah, it is.
I think it is the I don't like to say human, because I always believe human is not designed to do error. Any one of us don't like to do error. We all like to be good, looking good, and being perfect. However, I think the right thing is to say the process or the procedures that is in place. That's making the people making an error. So let's take an example, okay? I have a machine, and this machine is doing an alarm every 10 minutes, okay? So the first 10 minutes, the guy will go and look at the machine, and when there is an alarm, he won't understand that alarm, or he will say, hey, there is an alarm, it's not working, can you fix it? Nobody fix it. 10 minutes after, alarm. 10 minutes after, alarm. You know what? At the end, you say, okay, just keep it the alarm. I don't care about the alarm. And then for this time, there is an alarm, and this alarm is true, but you don't care because it's not working. So is it the human here? No, it's not the human. It's the process. Is the process. He has, in this case, he said there is an issue. We didn't fix it, and then he lived with it. So I don't think it's the human. And is it the machine? I mean, is the human who is doing the machine, and it's the human who is making the machine do it. So again, is being on the process of the machine.
That's a bit of a chicken or egg situation, right?
Yes, exactly. I think it's all about the human is the main factor, of course. If he is not adequately trained, if it is not respecting the procedure that is in place, and if you don't allow to the human to have improvement process. So it's important to get the people from the field to say, hey, this is not working, the procedure you have put is not working, this is the way we should be doing. And listening to them and making and implementing what they think is the best, because they are the guys on the floor doing the stuff. So they know it better than anyone else.
There's a good response to that in the chat. Good humans with bad machine, or good machine with bad humans? Might be a combination there. I like that. That's
I like this one.
We hit 6:30 here, so I think respect everyone's time, and we'll call it here. I can't thank you enough, Walid, and everyone from the STERIS team. Really appreciate the time you took today. Thank you for the presentation and the knowledge. Tons of great comments here, so I think everyone really appreciates the presentation. Speaking of the presentation, there'll be a link to the recording and the slides for everyone to review. And of course, you see Walid's email there. He's happy to help out if you reach out to him. And then finally, about other Singapore ISPE events, reach out to Christina. And there's a new newsletter coming out in the middle of January, or not January, July. Take a look at that, and have a good weekend. Stay safe, everyone, and take care.